Hello, everyone. I'm talking from Brazil. I hope you are safe and well. My name is Debora Lamberty, and I'm a researcher at the Geological Survey of Brazil. My area of expertise is in urban geology. Today, I'm talking about lessons learned from the risky areas mapping of Santa Catarina State, Brazil. This work was developed with the contribution of my colleagues Angela Bellettini, Renato Mendonça, Carlos Augusto Peixoto, and Júlio Lano. So, between 1998 and 2017, around 2.7 billion of people were affected and around 1 million of people lost their lives as consequence of intense rainfalls, which results especially in mass movements and floods. In Brazil, this situation is not different. After important events, especially Rio de Janeiro 2010 and 11, and Santa Catarina 2008, and so many others with hundreds of lives lost, the Brazilian government instituted a national policy for civil protection and defense, based in four pillars to manage the risk areas in Brazil and to work in order to reduce the losses in the events. The pillars we have here are prevention, mapping, monitoring, warming, and response. The government calls some institutions to work in this policy, and the Geological Survey was tasked to act in the mapping area by recognizing the geological and hydrological risk areas in all national territories. The process we map are mass movements, floods, and erosions. So here we have a timeline to highlight that in 2011 we started this work once we were tasked by the federal government to start the map risk areas in 821 Brazilian cities. Between 12 and 14, we work hard to achieve this goal. Once we have concluded the mappings, we continue work in order to make new mappings and also to update the maps made in the years before. So now we have 1,605 cities mapped, which correspond to 25% of Brazilian cities, and 180 cities with the maps updated. Our products, they are cartographic and textual, and first of all, they are sent as soon as possible to the city's managers. Later, we send the material to a database shared with government agencies responsible for the monitoring and warming of disasters. But all our data are available to the public on our institutional platforms. So when we talk about mass movements, we refer to the movement of soil, rock, or debris along a slope under direct effect of gravity. Mass movement here is classified in landslides, rockfalls, creep, and debris flow, as suggested by Augusto Filho. He has proposed this classification adapted to the Brazilian context, and that's why we use this classification in all the projects we develop in the Geological Survey. The objective of these papers this way is to present the results and to discuss some lessons learned with the mapping of high and very high risk areas in Santa Catarina State, southern of Brazil. But where is located Santa Catarina? So we are here in the south of Brazil, and the state has in the north Paraná. In the south, another Brazilian state called Rio Grande do Sul. In the west, Argentina, and the east, the ocean, the Atlantic Ocean. There are 295 cities in the state and a demographic density of 75 inhabitants per square kilometer. Just in order to compare, the HDI of the state is 0.774, a little bigger than Brazilians. The annual income per capita is around $8,000, while in Brazil is around $6,000. Based on it, Santa Catarina can be considered a developed state with good conditions when we compare with others in national territory. The geological and geomorphological context of the state can be divided in four main groups. First, in the west, we have an acid and basic volcanic rocks. Let me get the point here. Acid and basic volcanic rocks associated to a plateau-type magmatism. We call this region the Serra Geral group from the Paraná Basin. The landforms associated with this geology are plateaus and desiccated plateaus. In the center of the state, there is a sequence of Mesozoic and Paleozoic sedimentary rocks. This desiccation of these rocks results in a transitional shape of the landforms with steps and escarpments, is in this region here, in the center of the state. Also, we have in the Precambrian terrains a very complex geology with a sequence of metavolcanic and metasedimentary rocks, also a batholith with undeformed and deformed granitoids here in head, and in the north, especially old granulitic complex. The geomorphology associated with these rocks consisted with hills and ridges with high amplitudes and high slope angles, named Serra do Leste Catarinense, and a southern part of the Serra do Mar in the north of the state. Finally, there are Cenozoic sediments associated to flutes and coastal plains. Now, talking about the materials and methods, the material of this study is a database compounded by 1,577 risk areas mapped between 2011 and 2020 in the scope of the National Geological Risk Mapping Program. Reminding here that we only mapped inhabited urban areas with high and very high risk, which means areas where people can lose their belongings, but especially their lives. The mapping is based on an heuristic approach and included fieldwork activities developed by our geoscience researcher with the support of the local authorities, historical data research to identify past events, and image analysis using Google Earth facilities and GIS techniques. This database was consistent and analyzed in order to identify the main process and the correlated process, and to learn about what is given the real conditions to the development of these risk areas. What we got from this material, what are our results? So as I told before, we have 1,577 risky areas. They are distributed in 208 cities. Remember, Santa Catarina has a little bit more cities, so and 200,000 people lives in these risk areas. So we have an important amount of population affected by these risk areas. The most common process is the landslides, which represent 85.6%, followed by rockfalls, debris flows, and creep. I'd like here to highlight some points that I consider important. First of all, is in this region here, near Blumenau city, we have the biggest occurrence concentrations. Blumenau region has been affected by several intense rainfalls events is the urbanized region with highest demographic density. So of course we expected more risky areas too. In the west, where we have the plateaus and desiccated plateaus, the principal occurrence is concentrated in the desiccated plateaus, where we have biggest slope angles. And here is an example of the Rio do Peixe Valley. Is an important region of the state with high slopes and V-shaped valleys. Also, I'd like to highlight this area here in the southeast of the state, where we have a concentrate of rockfalls occurrences related to the weathering in granitoids, generating block fields. Last, these two regions here in the north and in the south, with so many occurrences of debris flow risk areas associated to the escarpments of the relief. Here, I'm going to point some characteristics we identify in each process, focus on the anthropic factors contributing to the occurrence of the mass movement. So first, the landslides, some characteristics as modifications and natural dynamics of slopes, constructions of slopes with high angles by cutting, changes in natural drainage of the slope, poorly performed embankments, sometimes with waste or inappropriate material, protection structures as retaining wall and drainage constructed without any technical support, and the removal of vegetation. In the examples here, we can see some characteristics, like the waste thrown in the slope. This waste can sometime in the future start an embankment and construct new houses in this area with embankment constructed by waste. Also here we have a very high angle slope constructed by cut. In this photo, we have a situation with high vulnerability houses. In this situation, even a small landslide can damage the house and can represent a risk area. And later, here we have a rotational landslide with houses in the bottom of the slope. It's not a high angle slope, but we have here a landslide that is affecting and damaging the houses. All these situations we can interpret as the human contributions for changing the natural dynamic and inducing the landslides. Rockfalls risk areas are related to the occupation around or downstream of block fields. As you can see in this first photo, we have a block field here and some houses here in the bottom of these block fields. Also, cuts in talus depots with so many blocks. Occupation inside the disabled stony quarry. As we can see here, it's a disabled quarry, and we have so many high vulnerability houses in the bottom of this quarry. And also cuts in the rock massive, very common in Serra Geral group. The debris flow areas were mapped included areas with previous report occurrences or with strong evidences as mountain areas or stream with high energy, especially associated to V-shaped valleys. Also, we have so many rural communities developed in plains areas in downstreams of this kind of susceptible areas. We bring here two examples. This one is older. It occurs on 2011 in Mirim Doce. We can see a lot of slope failures in the highlands, and in downstream, we see a community affected by the flash flood as the occurrence of the debris flow. This situation here occurs on last December. Also, we see the slope failures in the highlands, and inside the valley, a community affected, and here we have a lot of deaths associated to this debris flow. So, considering the big area potentially affected by debris flow and the potential to cause harm and deaths, it's super necessary to expand the identification of areas susceptible to these events. Finally, the creep, where we see occupation over talus and colluvial deposits, modification in slopes as cuts, and agriculture techniques inducing the creep. So here, first photo, we have a slope with a creep and vulnerability, high vulnerability houses occupying this slope, and probably in the future, this creep can affect this house and damage this house. Here we have a cut in the slope and the creep in development in this slope, and with a lot of evidences of instability. This example is a big area with a creep in development. The houses that was constructed in this area was damaged, and the people need to leave their houses. So, from the geological risk areas mapping in Santa Catarina, we have learned some lessons. They are the recognition of the most critical areas in each city contributes to the civil defense actions and municipal and provincial level, aligned to the national policy for civil protection and defense. The identification of the process allows actions oriented to solve problems according to the reality of each region. The way people appropriate these spaces is in many cases the main responsible for the risky areas. We see in the field works that sometimes a flat area with low susceptibility, which would be a safe place for construction, because of the way people construct the houses and manage the land, results in a risky area. So this means that we need to work. We are making mistakes in the development of our cities. We need to work in order to change this situation and the way we are working in our cities. The overview of the conditioners of the risky areas results in a demand of knowledge of the physical environment on a more detailed scale to understand the local characteristics and the natural susceptibility associated to these areas. The knowledge of the physical environment linked to safe forms of occupation is the key to the reduction of risky areas. And finally, the municipal documentations must define safe and unsafe areas for occupation, and also work in order to prohibit the urban development of areas susceptible to mass movements. So the project is completed 10 years, and we have learned so many things about how we occupy the cities, how we develop our cities, and how we should act from now to the future to reduce risky areas and to save people's lives. I would like to thank you for your attention, and I'm available to answer all your questions. Muchas gracias.